21st. Wow, I had a great meal today. It's a giant portion. I'm still kind of in a food coma. It's been almost 2 hours, but my belly is still protruding. Wow, that was some meal. It was gigantic. It's a Mexican restaurant with Beyond Meat burrito. It was huge, big boy size, definitely. Wow. Yeah, it's gonna take a while for me to digest, and I feel sleepy at the moment. All right, so it's an easy one, so we definitely need to go back to this. So whatever we did was not working yesterday, so we have to read the tutorial, understand the solution, and then redo it again. Did you hear what I said? Redo it again. That's wrong, because redo it is already means again. So either you say do it again or redo it. Alright, anyway, what's this one about? Divide string into groups of size k. As we want to partition into a group of size k using the following procedure. First group consists of the first k characters of the string. The second group consists of the next k, and so on. Each element can be a part of exactly one group. For the last group, if the string does not have k characters remaining, a character fill is used to complete the group. Note that the partition is done such that after removing the fill character from the last group and concatenating all the groups in order, the resultant string will be S. So we given an S, we want the size k, and the fill, we want to return the string. Okay, yeah. We'll just do it, and then we'll read the tutorial. I'm pretty sure in C++, I think there will be a method to get a substring out. Actually, I want to use it. I want to use it. I want to use it. So substring, string dot substring, right? Substring size. No. Position and then the length. Position and length. Huh. Right. We say rest dot push back. I. Okay. That sounds good. And then we say if rest dot size is smaller than k. Oh, how do we oof. Can we say new? Actually, I don't know. I mean, I can do the stupid way, but I want to see if there's a append. Append a string consisting of the same character to another string. Is there any trick that I can use? So I can use append. Oh, look at that. Is that true? I can say origin dot append number of times in a character to append. See, I did not know that. I did not know that. So you're telling me that if that's true, I can say res.size minus 1, right, equal to res.size minus 1 dot append count. Count is going to be k minus. Dear me, how many times I have to refer to this thing? I'll copy it out. I know I have to copy, but I don't have to write this all the time. So I can say last, and this will be k minus last dot size. Actually, if you think about it, it doesn't really give you too much benefit. So let's just do this. It's fine. It's fine. Holy crap. No matching. Oh, I have to give a character. My bad. Okay. Wow. See, that is what AI helps. Right? So this is basically something I don't know that exists. I'm actually not sure if AI is hallucinating or not. I can check. But it's basically a library function. I don't know. I mean, if I spend some efforts, I think I probably can figure it out. But I decide not to. Just, I decide not to. Which is, I mean, it's okay. So we still score very well. I wonder what's the best one. I actually have an idea. I'm gonna try. So yeah, this one did not score very high. 22%. Now here's another idea. I can prepend the fill to the end. So now we'll do the same thing. We don't have to do another check. I'm not sure if that is. I'm gonna try. Can try. So maybe we'll do. We'll do this one still, and then we can say how many is needed, right? So num to add, right? Num to add is going to be the size divided by k multiplied by k, right? And then we'll say s dot. What is this? This, actually no, it should be this divided by k multiplied by k, right? And then we use the total size. Yeah, we use the total size minus this. This will give me the remainder. Why you do that? You just want the remainder, right? If you want the remainder, you just get the remainder. This you get a remainder, right? Once you get a remainder, then you have to ask if the remainder is equal to 0 or the remainder is larger than 0. So we can say, let's say the remainder. Right, so we say the remainder is this, okay? And then num to add, right? Num to add, if the remainder is larger than 0, then num to add is k minus r. Otherwise, the remainder to add is 0. And then you will do s dot append num to add with fill, and then we do all this, and then we'll return rest. That feels right to me. Yeah, this is wrong. Okay, we'll give this a shot. See how this one goes. Is this one faster? Yeah, this one's faster. Oh. What does the editorial say? You can use and do string this dot fill. Dot back. Okay, so yeah, this is that. We don't have to do too much. All right, now we're gonna do the Manhattan distance again. Let's just see the. I don't want to read this. Let's just read the solution. Max distance. Everyone switch. So this is the counter times 1 modification times from north and south, modification times for east and west. Are you kidding me? So we get a counter of north and south and modification times. Basically, how many times we can modify in the vertical directions. So north, south. So basically, north and south, I'll do as much change as we can. And after we make the change, that means that part will be times 2. Yes. So it'll be, we go that much north, remove that much south, and we'll have a certain amount which is changed, which means that amount needs to be added back and added back. That's why you do times 2. How do you prove this? Oh, this is so much easier. Essentially, you count them, and basically when you change, it's either a north change to south or west change to the east, or the other way around, which just means you want to make changes to extend horizontally as much as you can, vertically as much as you can as well. And what this actually means is you don't want to change a vertical to a horizontal, because it doesn't really help. It doesn't make it better, right? I think that's what it means. It doesn't make it any better. So you don't have to. You just keep going. If I'm going north, just keep going north. If there's something going south, I will reverse it, right? If I'm going east and west, I will just reverse it. So you find out the difference between the two, right? You find out the minimum number you can change, because you want everybody, like ideally you want everyone to go in the same direction, right? You want to go to the same direction. So because of that, you take the smallest of that direction, you say, well, change all of them, and you take the other one, change all of them, and then you just make the change, and that's it. But here I am getting the latitude and longitude, x and y. So at the end, what you get is the final x and the final y. What the hell? Oh, so at each step, right? At each step, you are, at each step, you're trying to say, yeah, we can make a change. And each change will causing you k times 2. Actually, I don't understand. Any k of them increase the Manhattan distance by 2 times k. Why 2 times k? Because if you have k of them, then you always do 2 times k. But the max distance is I plus 1. That's the max distance. So you make sure you won't go beyond that. And then I have min max. This is, yeah, basically what it says is if we have more than k elements that can be changed, then at the end of the day, it will always be 2 times k, right? That's always what we can get more out of it. Oh, wow. I think I understood. Oh, that's pretty tough. It's pretty tough. But let's do one more code. Let's do it again. Okay, this solution. This solution is inspired by the first solution in the editorial. The idea is to find the frequencies, right, of all the directions and use and change and make change to the smaller, right, to the smaller on horizontal and smaller on vertical, if possible. Each change will make the Manhattan distance increase by 2. So what I'm going to say is north count, south count, west count, east count. Right? Okay, so we get that, and then when you say north in this direction, what's the smallest, the num chain, right? Change count vertical shall equal to the minimum of north count, south count, of course k, and change count horizontal k minus change vertical, right? And then when I return, basically std abs north count minus south count, right? But plus change this times 2 plus and abs west count east count plus change horizontal. But they're calling mean. Oh, my bad. I did not see that. Okay, let's give this a shot. Did I overflow? What? I don't think I need to do this because aren't they all initialized to 0? Huh? My understanding is not right. Well, I forgot the times 2. The first one's still not right. Alright, let's check. Where did we do wrong? Oh, it is not. It is not at the end. It's every single time. Holy crap. Okay, that was a wrong understanding. It's every time when we move at each point in time, we will check. Every point in time we will check. It's not at the end. Every move we will check right now. If I remove, if I do this, every time we'll see if I do it, will it become better? Every time we do it, will it become better? Oh, okay, that is different. So basically for each time we do this, get that. Find the frequency of all the directions. Right, and at each step, right, make changes to the smallest if possible. Current right, just like at every step you will check, like, can we make all of them in one direction? Can we make the other one making direction? So like every step you do as much as you can. And next step you try it again, next step you try it again. And we use this to establish. I still feel a little bit, I'm not sure. So at each step, I try to change everything to one direction. Yes, like as we just start, you will get the maximum. At a certain point, you can't, right? You can't. But overall, right, overall what is the thing, right? Overall, yes, overall, like at any step, you should know what is the maximum you can get currently, right? What the maximum you can get currently. And then moving on, you might not be able to get as much. Okay. Yeah, this way of thinking actually, I think that actually makes sense to me. I think you forgot times 2. So the other solution is you just keep finding. I mean, that's the same as this, right? This is the current position. This is the current position. And then you'll add these two together, which is just a change horizontal and a change vertical, right? We just need to know the change horizontal and change vertical. But it doesn't really matter, right? It doesn't really matter. This is the second solution from the editorial. We don't even have to keep track of the count of each direction, right? We just keep track of the position, right? The position of the what? Position of the point, right? Of the point. Now, if there are sufficient number, right? If there are more than, right? More than k directions that can be modified, can be changed. We can, the max max additional Manhattan distance we can get is k times 2, right? Also, at each step, the max possible Manhattan distance is index plus 1, right? Plus 1. Thus, we can find the max possible Manhattan distance at each step, right? At each step, taking into account the max additional, if possible, right? If possible, or limited by the max possible distance. So we don't need this, we just need x, y, res, right? So here we say right, if it's north, then x, now y plus plus, this is y minus minus, this is x plus plus. Okay, and then here is the magic. What do? Right, we have the current Manhattan distance, right? And then we say we can also get the maximum that you can have, which is 2 times k. And also it will all be limited, right? So we should say res shall equal to maximum res x plus, right, this is the current plus 2 times k. This is the maximum possible k, but it will be too much, right? So we also limit by this. This is I plus 1 is the max distance, right? Max distance. Because you start from I equal to 0, so you move out, right? So that is the current distance. Mm. 4 and 8. Oh, that's not max. It should be minimum. Still not right. Okay, so maybe it should be like this. This is the max, but we'll have another one. Minimum of these two. There we go. I think this one's right. 47. Okay, that will be it. I will see you guys tomorrow. Adios.